Okay, so today we're going to use two more sets of formulas. And these, not those. These right here are the ones we're going to use today. Handy dandy highlighter. Double angle identities and half angle identities. Okay, so some of these we have derived, which means I showed you where they came from, why they are what they are, and then some we're just going to use. So like the ones that we used yesterday, we just used. I showed you, this is what the formula is, this is how we're going to use it. That's the same for these today, like proving all of these or deriving all these would be a little complex. The ones tomorrow that we use, we're going to derive. So I'll show you where those come from. So the ones that we're not deriving are just a little step above what we are doing in this class. So that's why some of them I'm just like, here it is, this is how we use it. Others, I'm showing you where they actually come from. So with that in mind, I'm going to jump right in. And this is lesson 5.4. We are getting close to the end of the chapter. Multiple angle identities. Okay, so for example 1, we are going to prove one of the, it's called a double angle identity. Prove that sine 2 theta is equal to 2 sine theta cosine theta. Okay, so sine 2 theta is found in this double angle identity. Notice that all three of these have a 2 theta instead of just a theta. So that's why it's called double angle, because you are doubling theta. Okay, also notice that cosine 2 theta has 3 formulas that you can use. 1, 2, 3 different options. And where the 3 options come from is if you take this main cosine 2 theta and then you use sine squared and the Pythagorean identity and some substitution, it becomes that. If you take cosine squared and use some substitution from these, it becomes that. So if you want to use cosine 2 theta, you have 3 options there. Sine 2 theta, we just have this one. Tangent 2 theta, just one formula for that. We are proving this top one. Now, what does 2 theta mean? What does 2 theta mean? What does 2x mean? 2 times x? How else can I write that? What? No. That would be our half angle. Hold that thought because we'll get there when we get to the half angles. 2x can be written what other way? What? Okay. Think easier. Y'all are thinking hard. Okay, keep going. Oh. Come on.
Oh,
Not.
is it x plus a?
Yeah, so if you double something, it means you have 2 of them, right? So x plus x is 2x. So 2 theta could also be written as theta plus theta. That's how I'm going to prove it. I'm going to write it as theta plus theta and then use one of the formulas from yesterday. Okay? All right, so I am going to I'm actually going to take what would seem like the easier side here and change it until we get that. Okay, so I'm going to change this side into sine theta plus theta. That's what 2 theta means, theta plus theta. Then I'm going to use the sum and difference formula that we had yesterday. It's just that with my A and my B, both of them are going to be theta. Okay, so it's sine, and there's a plus in the middle. So when I get over here, I will also use a plus. Okay, so using this identity, it will be sine of the first angle, which is theta, times cosine of the second angle, which is also theta, plus cosine of the first, which is theta, and sine of the second, which is theta. Okay, multiplication is commutative. What does that mean? You can switch it around. Isn't 2 times 5 the same as 5 times 2? Okay, so isn't sine cosine the same as cosine sine? So if I have that plus that, what does it equal? 2 of those things, right? 2 of these things. And look what we were trying to prove. That it equals that. So there's our proof. Question on that. Okay, second example. Solve for x on the interval 0 to 2 pi. Okay, so just those directions tell me, hey, eventually I'm going to be looking on my unit circle for something that fits, makes it true, and I'm going to go from 0 up to 2 pi, but don't include 2 pi. So basically the entire unit circle, but I will use 0 and not 2 pi. Okay, so here's my equation. Sine 2x equals cosine x. Now, I don't know that we can just look at that and figure it out. Like, maybe if we sat here long enough, we could look at the unit circle and figure out that answer. But what I'm going to do is use that double angle that we just proved. So I'm using this double angle right here, and I'm going to change sine 2 theta into this. Now, the advantage of that is these just have thetas. They don't have 2 thetas. So I'm going to take the left-hand side and turn it into what we just proved up here. 2 sine cosine equals cosine. Oops, and I changed the thetas midstream. Stick with x or stick with theta. Now we're talking about theta. Okay, how did that make it easier? This had a 2x. This only had an x. Now they all just have x or theta. So there's no double angle anymore. How would you solve it from here? And let me tell you what we can't do. I can't divide both sides by cosine theta because I'm getting rid of a solution. If there was just a 2 in front of both, yes, I could divide by 2. But I don't want to divide by the variable because I'll be eliminating a solution. Okay, so other than that, what would you do? What if I had 2xy equals x? What could we do with that? What? I'd still be getting rid of a variable, though. I would subtract x. And then what? Because those aren't like terms. Factor out the x. Okay, that's what we're going to do here. So I'm going to subtract cosine theta, or x, if you still have x in yours. Are those like terms? Can I subtract those cosines? Unfortunately, no. Okay, but I do have two terms that both have a cosine in them. So I'm going to factor out a cosine, and that leaves 2 sine minus 1. Everybody okay with that factoring? Okay, if this times this is 0, yes?
When would you know how to, when to factor?
That, unfortunately, is something that the more you do, the easier it gets. It's not something squared, right? And I can't add these together because they're not like terms. So really that's my only option here if I'm trying to solve it. But again, practice makes perfect, hopefully. So you're looking for those patterns like, oh yes, something like this has happened before. We factored out the common factor. So you're kind of relying on the patterns that we've seen. Okay, cosine theta equals 0. And 2 sine theta minus 1 also equals 0. The only way I get a product of 0 is if at least one of these things happens. That, I'm going to look at my unit circle. This, I'm going to do a little more work. I'm going to add 1 and divide by 2. So 2 sine theta equals 1. Sine theta equals 1/2. Now I'm going to look on my unit circle. Okay, so let's go back to this one. Where on the unit circle is cosine equal to 0? Do you see any place where cosine is 0? 90. Okay, since the directions were given in radians, let's answer in radians. So 90 is the same as what? Pi over 2. Do you see cosine of 0 anywhere else? 3 pi over 2. Down there at 270. Okay, that's it. Shouldn't find any more that fit that, but what about where is sine 1/2? Here's sine 1/2. Pi over 6, which is 30 degrees. And 5 pi over 6 over here in the second quadrant. And that's it. Those are my 4 answers. Questions? Okay with those? All right. Next. Sample 3. I'm going to do some radical practice here. Find the exact value of 22.5 degrees. Oops, and I forgot a cosine in front of that. Cosine 22.5 degrees. And I'm going to write more to these instructions in just a second. Is that on the unit circle? Certainly not. But that is half of an angle that is on here. Which angle, if I take half of it, will I get 22.5? 45. So we are going to use a half angle identity. Okay, so our half angle identities, notice that they all are something over 2, hence the term half angle. So you already told me that if I take half of 45, I'll get 22.5. And it's cosine, so we're going to use the cosine formula. 45 divided by 2 gives me the angle that I want to find the cosine of. So I'm going to say cosine of 22.5 is equal to cosine of 45 over 2. Is everybody okay with that? Okay, so looking at the formula, notice that theta is right here. So what is my theta? 45. So anywhere in this formula that we see theta, we are using 45. Okay? So let me make a little note that this is theta. In the formula, when I see theta, I will use 45. Okay, so let's set up the formula. Oh, notice this, plus or minus out front. Okay, in some quadrants, cosine is positive. In some quadrants, cosine is negative. I am looking for cosine of 22.5. Which quadrant is that in? The first. Is cosine positive in the first quadrant? Yeah, everything's positive. So I will choose to use just the positive out front. Not the negative, just the positive. And with positive, you don't have to put that there. I'm just putting it as a reminder that, yeah, we figured out we need the positive. Okay, then I have this big square root. And I have 1 plus cosine theta, but remember theta is 45, over 2. Everybody see where I got that set up? Okay, I'm finished with the left. All I'm going to do is simplify this side. Okay, which is a little bit harder than it sounds. Okay, look on your unit circle and tell me what cosine of 45 plus 5 is. Cosine of 45. Anybody? Square root of 2 over 2. And then all of that is over 2. Take a wild guess. What do you think I'm going to do next? How? I'm going to add those together. What do I have to do to add those together? Common denominators. Okay, this is technically 1 over 1. And I want to add it to something over 2. So what does the denominator need to be? 2. This one's good. Leave it alone. But this one I need to multiply by 2 over 2. Okay, so my new and improved fraction is 2 over 2 plus square root of 2 over 2, all that over 2. There's like a 2 everywhere. Okay, these now have common denominators, so I can add them. And that gives me 2 plus square root of 2 over 2, all over 2. Stop me if you have a question. Okay, this is technically 2 over 1. So I'm going to do 2 plus square root of 2 over 2 times the reciprocal of that. You can also do the little shortcut that I take. But what happens to the denominator now? It becomes 4, right? Now 1 times that numerator is just going to be the numerator. 2 plus square root of 2 is now over 4. But wait, there's more. What's the square root of 4? 2. This top, that is not a perfect square. It is going to stay under the radical. But square root of 4 is just plain old 2. So my final answer will be that over plain old 2. But you've never had a square root under a square root, but it's okay. It can happen, and we can leave it like that. Question. I will say that those are probably as bad as they get today. But, oh, let's do another one. Did I hear someone say that? Yes, I did. Y'all's hearing is no good. You listen to that music so loud, it's bad. Pretty sure I heard somebody. I think it might have been
Yeah, it probably was.
said, Miss Campbell, can we please do another one? Angle identity for 75. What angle divided by 2 gives us 75? 150, sure? 100%. I agree. Okay. So we're going to set up sine of 150 over 2. Okay, because 75 is not on the unit circle, right? So we need another tool to find that other than our calculator. So we're going to use this 150. Okay, looking at your formula, you have that little plus or minus out front. I'm finding sine of 75. Which quadrant is that in? First. Even though 150 is in the second, what I'm looking for is the sine of 75. And 75 is in the first quadrant. It is positive, so I will use the positive again. Even though 150 is in the second, what I'm really looking for is sine of 75, so I know that that answer should be positive. Okay, so big square root. And let's look at our formula. Half angle for sine. It looks a lot like the one we just used. With what difference? There's a minus instead of a plus. Other than that, they're identical. Okay, so I have 1 minus cosine 150 over 2. And let's just keep subbing in, simplify the right. 1 minus, what is the cosine of 150? What? What's that? Negative square root of 3 over 2. And all that's over 2. Okay, but when I subtract a negative, it will become positive. Okay, I need to add these. Therefore, I need common denominators. What does 1 over 1 become if I need a denominator of 2? 2 over 2. Okay, I'm just going to write that. If I lose you on that, let me know. It's almost just like the last one. It's just slightly different numbers here. Okay, I'm going to add them. 2 plus square root of 3. Those are not like terms, but I have my common denominator of 2, and all of that is still over 2. And that is technically 2 over 1. Okay, so if I do my little shortcut on this one, then I get 2 plus square root of 3 times 1 is just 2 plus square root of 3, and 2 times 2 is 4. You can also multiply by the reciprocal of the bottom there. Top 2 plus square root of 3 is certainly not a perfect square. It will stay under the radical, but 4 is a perfect square, and it becomes what? 2. So it becomes plain old 2 because square root of 4 is just 2. Not under the square root anymore on the bottom. Question? All right, let's do another equation, and that'll be it. These are kind of short and sweet lessons. Okay, let's do another solve, because I heard someone ask for that. solve cosine 2x equals cosine on the interval 0 to 2 pi. So at some point, I'm going to have to look on my unit circle and find an answer. Do you know what the answer is based on that? Let's do a little work. Which formula section am I going to for this? The double one, right? Cosine 2x. Okay, let's look at cosine 2x. This is the one I told you. You have 3 options. We can replace it with that, or that. Doesn't matter. Is one going to be easier than the other two? I think yes, but which one? Okay, so if I use the one with cosine squared and sine squared, then I will have a cosine squared and a sine squared and a cosine. If I use the middle one, I will have 2 cosine squared, a 1, and a cosine. If I use the bottom one, that one is my least favorite because I have sine squared and cosine. Any idea which is best? The middle, because it will only have cosines. Okay? All right, so on the left, I am going to replace it with this 2 cosine squared minus 1. And I'm going to stick with x's this time. I'm not going to switch it up. 2 cosine squared x minus 1 equals cosine. Okay, so what I accomplished is now I just have cosines. But I've got this thing over here. Should I move it? I think so. This one is kind of annoying me. So let's see what happens. Why did I put it in the middle of those two? So I can factor. It is a trinomial that will factor. Think of this, 2x squared minus x minus 1. That's basically what we have here. How would you factor that? Would you make the x? I'm going to do my guess and check because these are small numbers. 2 and 1, I think we can figure it out. Okay, go to the first term. What 2 things do you multiply to get 2 cosine squared? 2 cosine and 1 cosine. Let me write it out and then we'll go back over that. Okay, what if I multiply those 2 together? That gives me 2 cosine squared, right? If I were doing that over here, I would say, what do you multiply to get 2x squared? 2x and x. Okay, go to the back constant, 1. What do you multiply together to get 1? 1 and 1. 1 and 1 go there. Okay, think about foiling this. First outer, inner, last. The outer and the inner products, these 2 products here, are what give us that middle product. So what do the SIGNs need to be there? Plus, minus, minus, plus, both minus. Minus, plus. Okay. Minus, plus. Foil that out in your head. Do you get a negative cosine? It's the opposite, yes. Plus, minus. Now if I FOIL it out, I get a negative 2 cosine and a positive 1 cosine. Add those together and we get the negative 1 cosine. Okay, so here are my factors. After we factor, what do? Set them equal to 0. Okay, on the left, I'm going to do what? Minus 1 divided by 2. Okay, on the right, I'm going to add 1. Okay, so these are the two things that I'm going to look for on the unit circle. Where is cosine -1/2 and where is cosine 1? And I'm looking on the entire unit circle, 0 to 2 pi. Okay, let's start with cosine -1/2. Where do you see that happening? Did you say 2 pi over 3 or pi over 3? 2 pi. Okay, good. Okay, 2 pi over 3. Anywhere else? 4 pi over 3. Anywhere else? Nope, that's it. Okay, so let's go to cosine equals 1. Where does cosine equal 1? 0. Do I use 2 pi also? No, because of the parentheses at 2 pi. So that's it. Cool? Okay. You have a lot of time again, 45 minutes, to work on, I don't know why this says due Thursday. That is not accurate. No, then you would just procrastinate. You have 45 minutes to do it right. You should be able to get those done before you leave, just like yesterday. Okay? So scribble out that due Thursday for me.